All right. Day 2 out of 2, product and quotient rules. But now we've joined trig derivatives are going to get thrown into the fray as well. Yep. We already know that the derivative of sine is cosine, and the derivative of cosine is negative sine. We had to learn that in the previous section, and I introduced the rest of them to you at that time as well, but we didn't need them yet. But now you need to know all 6 of them, and you need to have all 6 memorized. You should know before I move this screen shade thing here that the derivative of tangent is, well, of course it's secant squared of x. We all know that. In fact, here are the rest of them right there. And like I said before, really you're memorizing them in groups of 3. If you memorize the red ones, the blues will follow. For example, if you know that the derivative of tangent is secant squared, when you put a co on that tangent, it's the same answer. You just get a negative and a co, so it's negative co secant squared. If you know that secant is secant tangent, then you know that co-secant is negative co-secant co-tangent. Just throw on some negatives and throw on some co's, and you're good to go. So really, you're not memorizing 6 things. It's more like 3 pairs, which makes it a little bit easier. I just briefly want to show you why this is true. I graphed sine in red and cosine in green, and I want to show you that the derivative of sine is actually cosine, and you can see it from the graph. You can see it visually. Let's start with sine, and these x values are going by 90 degrees, or pi over 2. So this is actually pi over 2 right here. This is pi. It's 2 pi out on the edge. Let's start with the sine graph first, since it's the original and the cosine's the derivative. Sine of 0 is 0, of course. But I know that sine of 0 is 0, but what's the slope there? Well, the slope there looks like you're going up 1 and over 1. So the slope is 1? Yeah. Okay. Let me plot that. 1. All right, let's go elsewhere. Following the sine curve right here, at pi over 2, the sine is going to be 1, but what's its slope? Well, the slope there looks like it's 0. Okay, we'll graph that then. All right, 0. You can see what's happening. Let's do a couple more. Let's move ahead to right here. Sine of pi is 0, and that's great, but what's the slope there? Well, it looks to be, I don't know, negative 1. Okay, graph it. All right, negative 1. Oh my gosh, we are forming cosine. The derivative or slope, remember derivatives are representations of slopes. The derivative of sine is cosine. All right, one more just for fun. You're down here. That's the sine curve. You're at negative 1, but the slope's not negative 1. The slope is 0 there. It's a minimum. And if the slope is 0, that means that your graph is back on the x-axis. We are graphing the derivative of sine. It happens to be cosine. I'm not going to bore you with the other 6, but I could prove them just as easily. In fact, tangent, you know what the regular tangent graph looks like. It's the series of S-curves. Kind of looks like that. And then there's an asymptote, and then it starts to rise again. Tangent is always rising. It keeps getting, cut off by the vertical asymptotes, but it's rising. Is it not surprising that if you're rising all the time and your derivative, no matter where you're at, is always positive, positive, positive? Wouldn't it make sense that your derivative is secant squared, something squared that can't go negative? Intuitively, that makes complete sense. All right, let's try some problems now using trig. All right, find the derivative dy dx. What's the derivative of cosecant? Well, it's negative cosecant cotangent. So negative cosecant of stuff, cotangent of stuff. Now people will get on me. They're like, wait a second. Why did you put the 4x? I thought it was just x both times. I'm like, no, whatever this is, these will be the same both times. Well, that's not what you had on your display. I'm like, look, I can't anticipate every possible thing in the world that might be on a math problem. So whatever this is, I just made it X, it's generic. You will replicate it here and here. So if it's an X, great. If it's a 4X, then these need to be 4X's and so forth. If it's a WXYZ, that's what you copy. All right, so don't think it's just plain boring X all the time because of my slide. Now, another problem rears its ugly head. And again, this is a little bit out of order. You shouldn't know about this yet, but does 4X have its own derivative? Oh, yeah, it does. Times 4. Well, you need to multiply by it. Instead of putting it on the back end, I'm going to put it here. That's why I left a space behind the minus sign, because I knew that was coming. Little dot. All right, so that's the derivative of the first part. Plus the derivative of cosine, but I know that the derivative of cosine of stuff is negative sines. I'm going to go minus sine of stuff. This time the stuff is the 8x to the third plus 5. By the way, stuff is a very unmathematical term. Officially, the thing behind the word sine, cosine, and tangent, maybe I've told you this already, is called the argument, which is a really strange thing to call it, but that's what it's called. So the 8x to the third plus 5 is the argument. Sometimes you're programming, whether it's on your graphing calculator or just on a regular computer, and you'll see something that says error arg, and it looks kind of piratey. It's not arg, it's short for argument. That means that something in here is wrong. So if you're trying to code and fix your code, that's where your mistake is. It's in the parentheses. So go get it. All right, does the argument have its own derivative as a chain rule? Oh yeah, it does. The derivative of 8x to the third is 24x squared. It's going to go out front because it's better out there. I don't like to put the 24x squared at the end because then some people think that it's getting trigged. You know, they think that the sign is also being done to the 24x squared. I'm like, no, just the sign's just being done to the 8x to the third plus 5. So that's why I like to put it in front. Hey, that's the answer, you guys. It looks terrible, but it's correct. Now, some people will ask, hey, you want me to factor out a -4? I'm like, you don't need to. I mean, if you want to, you can, but no, it's just as well. Just leave it like that. That's great. The only time I demand that you factor is if you have an equation and you can divide both sides by something, or maybe you have a fraction. You can factor something out of the numerator and denominator and they can cancel with each other. But here, no, we're good. All right, find the derivative, dy dx. Y is 5x to the fourth times tan. Oh, I said times. I sure did. There's a big multiplication dot. You know what that means. Oh, yeah, you do. That's a U. That's a V. Get your fingers ready to start snapping. We got some product rule coming our way. U prime V plus UV prime. All right, note to self up here. What is U prime? Well, it's just 20x to the third. And V prime, I got to deal with a little bit of trigonometry. The derivative of tangent of 2x is secant squared of 2x. Ooh, that has an argument, though. Does the 2x have a derivative? Yes, it does, times 2. All right, I'll put it in front where I left that little space. All right, now I'm ready to go. U prime V plus UV prime. All right, U prime V. Plus U V prime. Okay, that would be the answer. People will say, hey, should I factor out an x to the third? Not necessary. You can if you want. I think you could just leave it like that. That's fine. One thing I would like you to do, though, this is 10x to the fourth. Don't leave it like that. That's strange. Go ahead and write 10x to the fourth. And that's it. All right, here in number 9, we have secant of x over x squared. This is definitely going to be either a product or a quotient rule. I have found over my many years of experience, it's better to leave the x squared in the denominator, I think. Some people disagree. Some people are like, I'm bringing it to the top. I hate fractions. I secretly loathe the quotient rule. I'm like, okay, well, I love it. Love it or loathe it, right? I'm gonna keep it. I hate the negative exponents that you're dealing with. So pick your poison, right? Find dy dx. I should point out that both methods do work, though. All right, u prime v minus uv prime over v squared. V squared is going to be x to the fourth. X squared squared. All right, u prime v. The derivative of secant is secant tangent. U prime v minus uv prime all right. Well, that does need to be simplified. In this case, we do want to factor out an x because we can cancel it with the denominator. Or if you would like to just do it on the fly, suppose I'm cool with that. Just make that an x to the third. Just steal an x from each of these, so that's x to the first. This is just going to be a 2. All right, can we factor out a secant? Yeah, you can. Yeah, why not? Sure, I'll do it this time. This is optional. If there was a secant of x in the denominator, I would expect everybody to have to do this. That's going to leave us with x tan x. I like to write the x in front. That way people are not like, is that tangent of x squared? I'm like, no, it's x tan x. All over x cubed, and that is the correct derivative. Some crazy looking answers, but we're integrating trig right into this. This is great. All right. Let's pick up the pace a little bit here. dy dx or y prime. Quotient rule, trig, I'm good with the derivatives. We got u prime v. That's going to be cos x, cos. I'll just put a squared on it. Okay, u prime v minus u, which is just the numerator, sine of x. V prime, which the derivative here is negative cos. I'm sorry, negative sine is what I meant to say. So, okay, that looks cool. Over v squared, which is cosine of x squared. All right, that looks pretty crazy. I don't know if I want to deal with that quite yet. You know what we could do? This is actually going to be negative times negative. That'll be plus plus, and that's just sine of x squared. You can write the squared on the outside of the parentheses, or you could write it as sine squared x. Oh my gosh, you guys. Up top in the numerator, we have sine squared plus cosine squared. That's 1. Thank goodness for the golden sheet. So that's 1 over, I'm going to write this as cosine squared x. But you know what 1 over cosine squared is? It's just secant squared. And so the answer to this problem is secant squared x. Woo, that's the derivative. And then I look around and my friends are all laughing at me. I'm like, what? And they're like, dude, what did you do all that for? Like, what do you mean? And they said, Mr. Luce just gave you tangent. Y equals tangent of x. What's the derivative of tangent? Yeah, it's secant squared. And you're like, oh my gosh. Well, I just proved that it works. Yes, you did. So again, there are longer and shorter ways to do things, but no matter what way you pick, as long as you're doing the correct things that I've taught you, you're not going to go wrong. The problem might be long, but it won't be wrong. All right, no more rhyming, I promise. Let's move ahead to number 11. Oh, ouch. Oh, that's wicked. Yes, it is. But so are we, so let's go. I'm going to rewrite this using some algebra 2. I'm going to call that to the 1/3 power. This problem involves a little bit of algebra 2 that I just did, but it also involves power rule, quotient rule, and chain rule that we're not even supposed to know about yet. So a good portion, probably almost half of chapter 2 is involved just in this number 11. All right, there also is an invisible 1 in front that now you can see. So the derivative dy dx is going to be exponent times coefficient. 1/3 times 1, of course, is 1/3. Stuff to the go down by a power. 1/3 minus 3/3, which would be 1, would be negative 2/3. The stuff inside just gets brainlessly copied. But here's the bad part. Does the stuff inside have its own derivative as a chain rule? Oh, you bet it does. In fact, it's a quotient rule. Oh, no. Oh, yeah. So we have a u up top. We have a v down on the bottom. Luckily, neither one of them are that bad. All right, u prime v, that's going to be 2 v's. U prime v minus u v prime. Now v prime is just 5. I'll stick it in front because it's easier. Over v squared. Okay, how about that? Now don't leave your final answer looking like that. That is atrocious. We have some work to be done here. How about 10x plus 8 with a little distributive property? Let's distribute this entire negative 5, we're going to think of it as, into the parentheses. So that's minus 10x, which is delightful because it's going to cancel the positive 10x out. And negative times negative will be plus positive 13. 8 plus 5, that's just a 13. All right, let's see what we have. Okay, I brought that down. We're going to bring down the 1/3 as well. But then we've got this issue. Anytime you have a negative exponent and there's a fraction inside, I don't know if you realize this or not, you're allowed to flip it upside down, use the reciprocal, and then the power changes back to positive 2/3 on the exponent. So if you want, I can rewrite this. I can make this 5x plus 4, taking over the numerator. The 2x minus 1 will become the denominator. And because I made that exchange, this is no longer there. It's now a positive 2/3 power. So that's kind of cool. But what's even cooler is you're allowed to split them into their own 2/3 powers. This is all Algebra 1 and Algebra 2. These are all legit steps. So you get the 5x plus 4 here and the 2x minus 1 here, both of them to their own respective 2/3 powers. All right, what made me do that? Well, I saw the ability to cancel because there are 5x plus 4s both in the numerator and denominator. Here there are 2/3 of them. And you see this 2 down here? Yeah, this 2 that's changing to a 6/3, which is still a 2. I can cancel. And so I'm going to be left with 5x plus 4 to the 4/3 in the denominator once that cancels away. That'll become a 4/3 by subtraction. So in my final answer, all I'm going to have in the numerator is a 13. Everything else has become a 1. And in the denominator, I'll have 3 times 5x plus 4 to the 4/3 times 2x minus 1 to the 2/3. Let me clean this up. And that is dy dx. As you can see, there's a lot of algebra involved in calculus. And sometimes it can be the harder part of the problem. Taking a derivative isn't always the worst thing in the world. Okay, 4 more problems. These are a little bit more of the quick hitting variety. It says, use the given information to find f prime of 3. F prime of 3. Well, before I find f prime of 3, I have to be able to find f prime of x. Luckily, f of x is right above in black, but unfortunately, you can see already what they're testing. This is a product rule. It's g of x times h of x. So I have to do this with different letters. It's going to be g prime h plus gh prime. That's hard to do. But okay. There we go. G prime h plus gh prime. All right, now, I don't want to find f prime of x. I want to find f prime of 3. Easy enough, I'll just turn all the x's into 3's. So f prime of 3 should be easy now. G prime of 3, that's going to be 2. H of 3, not h prime, but h of 3 is 5. G of 3 is the 7, and the h prime is the negative 8. And it's looking like negative 46. And you can see what a great multiple choice question this could be. You just have 4 easy choices that are all just numeric, and you really can test the product and quotient rules without saying that that's what you're doing. A lot of students who have no idea what's up come May, they see this problem and they're like, oh, f prime, that's just g prime times h prime. Ouch. And so they don't have this or this, which means if I wanted to do a fake answer, I'd just have 2 minus 8. I'd have a fake choice of negative 6. And they're like, hey, there's my answer. They'd all pick it. It would be wrong. And they would never know why they got a 1 or 2 on the AP exam. They just, oh well. So again, they're testing the product rule here. I'm testing the product rule. I made this. I can also test power rule and chain rule with the same approach. Like lucky number 13, find f prime of 3. Again, we want to find f prime of x first. The derivative of 6g of x is just 6g prime of x. Okay. Remember, there's a 1 in front here, so this next part, I'm using the power rule, so 2 times the negative 1 in front is minus 2, or negative 2. Stuff inside the parentheses, which is just h of x. Actually, I guess it's brackets. To the first, which I won't write, that's the 2 going down by a power. Oh, but is there a chain rule? Does this thing inside the brackets, the h of x, have a derivative? Well, yeah. H prime of x, of course. It almost seems too easy. It's getting easier. All right, again, we don't want f prime of x. We want f prime of 3. So, okay, we'll turn all the x's into 3's once again. All right, here we go. F prime of 3 will be 6 times g prime of 3, which is that 2 right there, minus, we have a 2, an h of 3, and an h prime of 3. H of 3 is 5. H prime of 3 is the negative 8. See what this makes. We've got 12. Minus negative, that'll be a plus. 2 times 5, that's 10 times 8 is 80. 80 plus 12, it's 92. All right. Last but not least, a lot of times you'll see problems where you'll have a chart, which is basically what we just did, except there's more information than you're going to need. They say, let f of x be g of x divided by h of x. I can sense some quotient rule coming on. Find f prime of 5. Okay, again, to find f prime of 5, first we need f prime of x. And since f of x is g divided by h, the g sort of becomes the u. So we're going to have u prime v minus u v prime over v squared. As you can see, I replaced all the x's with 5 since we're looking for f prime of 5 instead of f prime of x. And all the information is right there in the chart or the table. I just have to make sure not to screw it up, so I'm ready. H of 5 is right here. It's negative 1.0. I'm not sure why the decimal's on it, but that's okay. We're going to square that, which is just positive 1, which means we don't even need the fraction bar anymore. Yes. Okay, that was awesome. All right, let's see. G prime of 5. G prime of 5. That's negative 6. H of 5 is still negative 1. G of 5 is going to be 1/4. And H prime of 5 is this 8 right here. So we're going to end up with a 6 minus 2. And I can tell you that that is 4. And that is correct. Again, these lend themselves really well to either multiple choice or free response. You can test this in either style problem. All right, one more, last one for section 2-3, number 15. We want f prime of 7. Let's get f prime of x first. Let's see what this involves. The derivative of 4h of x is just 4h prime of x. Okay. Plus, the derivative of h of something is h prime of that something, that argument. Wait, does the argument have its own derivative? Because if so, that's a chain rule. Yes, it does. What's the derivative of g of x? Why, g prime of x. Okay, we'll multiply that by that then. Most students who don't get this problem right don't get it right because they forget to put this on the end. So if I want to come up with a trick answer, I just work the problem incorrectly and leave this off. Of course, I don't want it left off, so let's bring it back. All right, we're going to find f prime of 7. So I'll make all the x's into 7s right now. All right, let's see what f prime of 7 will be. This 4 goes down there. H prime of 7, that's negative 2. I'm going to come back to this later. Okay, at the end, g prime of 7 is 11. That's right there. What is this? Let me dig into this a little bit deeper. G of 7 is 5. Okay, so this thing right here is a 5. So now I have to figure out what's h prime of 5. Oh, this is clever. H prime of 5 is 8, so I had to come back up to the middle row again. So this is going to be an 8. Now let's just drop the 8 into the parentheses. There you go. And now we'll solve. Negative 8 plus 88 is 80. And that concludes day number 2 of section 2-3. We learned about the product rule and the quotient rule. We had some chain rules sort of sprinkled in as well as the power rule, which we already knew. And we put some trig in as well. We've just done a whole bunch of stuff. So hopefully it went well for you. And I'll see you next time for lesson 2-4, which is the official version of the chain rule. Until then, take care, my friends.